Thank you for inviting me to give this talk and for joining me. My name is Mark Spalding. I'm a senior marine scientist with the Nature Conservancy based out of Siena in Italy. I'm also an honorary research fellow at the University of Cambridge, where I have a small team who I work with on what I'm about to talk about, which is what we call mapping ocean wealth. And it's been an ongoing series of projects really to try and understand the value of nature to people and to build that value into maps. Ecosystem services, the value that we get from nature, have been quite a focus for a lot of people for many years, decades. And a few brave scientists have really set their sights on trying to calculate the total value of nature to people. These are extraordinary numbers, eye-wateringly large, but apart from grabbing a headline, they're not all that useful. What we're talking about is things like the role of oysters and other filter feeders in cleaning our waters, the role of coral reefs in protecting and defending our shores, the role of complex structural habitats as feeding grounds and breeding grounds for fish, which of course we then benefit from as we eat. But the point, I think, behind this is there's a lot of science. It's not just, yes, we know these things are important, but we know exactly how important they are. We know that an adult oyster will filter 180 liters of estuary water per day, that a coral reef will break waves. Over 90% of the wave energy is reduced as it comes across a coral reef, and so on. I want to talk about mangrove forests. These are the forests that in the intertidal zone of the tropics, amongst the most productive ecosystems on the planet. They pack carbon both into the living biomass and into the muddy, waterlogged soils underneath them. They're tremendously important in mitigating climate change. We knew that. With my colleagues in Cambridge, we went to the literature and we scoured the literature. And we found cases, examples where we knew the biomass of mangroves from every continent across the planet. You can see from the pictures below that there's quite a variance from massive 30-meter high canopies to little shrubby desert mangroves. What we did was we took those numbers, those data sets, and we tried to fit them to what might be driving that variance. And not surprisingly, climate was a major part. So we found by using data on temperature, precipitation, and seasonality, we were able to build a model that was a reasonably good fit. From that, we could go from the site-specific studies to the global map. This is the first global map of mangrove biomass. And it shows the hotspots, and that shows the areas where we really need to give attention, both to mangrove protection and perhaps even to restoration. These are the places which are really acting as carbon scrubbers for the planet. A completely different direction was our work on coral reef tourism and recreation. A tremendously important source of foreign exchange, of jobs, and of course of pleasure for a lot of people who are going out and enjoying diving and visiting coral reefs and lying on beaches near coral reefs. So our challenge was that there was no data on numbers apart from the national level statistics. So here you can see $2.3 trillion per year being spent on tourists going to coral reef countries. We wanted to know how much of that was anywhere near coral reefs. To get to that, we used photographs uploaded onto Flickr at hotels, and we basically spread those values across the entire countries, and then we clipped it, as you can see in this map, to only really look at the values that were near coral reefs. We then tried to understand how those values could be spread both to the people who just enjoy being near a reef, lying on beaches, enjoying the beautiful views or the seafood, what we call reef-adjacent values, and a bit more challenging to look at the diving and the snorkeling and the glass bottom boats, where we were using things like dive centers, dive sites, and also underwater photographs, which we were able to filter out from Flickr. And with that, we were able to pinpoint exactly not only the total values, but where the values were coming from, as you can see on that map. And this is the output. We were able to show 70 million trips were taking place because of coral reefs, $36 billion or so per year being spent on coral reefs. And you can see the darkest reds there. Those are what we call the $1 million reefs, where every square kilometer of reef was generating $1 million of expenditure per year. The concept is simple. A series of ecosystems on the left, a series of services across the top. And we're gradually ticking off some of those services and ecosystems around the world, developing these models. It's an exciting and important piece of work. And it's been massively collaborative. What we're trying to do, of course, is not just do the academics, but to put it to practice. to help guide restoration projects, to help guide local communities, but also the international agenda and so on. So these are some of the partners we've worked with, and this is the website. Thank you very much.